Hello, everyone. I'm going to be presenting a prediction of stress and mental workload during PoliceAcademy training using ultra short-term heart rate variability and breathing analysis. So stress and mental workload are one of the three main components of what is defined as operator functional state, which is the overall psychological state of a person. And this is something which is very critical to the job performance. As you can understand, if a person is too stressed, they're not able to do their job well, or if they're too tired, or if they have to use too many mental resources. So to study that using physiological signals has been done previously in stationary environments in controlled stimulus provided in laboratory settings. And a lot of physiological sensors have been used as correlates to the psychological constructs, namely EEG, EOG, etc. Now, with increasing number of wearable devices it is possible to monitor jobs that are ambulatory in nature. The person is running around and doing their job, and they have to go through the stress and mental workload scenarios. Though this provides a lot of challenges, some of them being mental movement noise, the change in biosignal dynamics, and faster response times are required in order to make real life decisions very quickly. One of the very good examples of such jobs is first responders like police officers and firefighters. So for our experiment, we used 27 police trainees who did a 15-week course at the École Nationale des Polices de Quebec in Quebec City. These people were equipped with breathing and ECG sensors. And this 15-week course consisted of various exercises that police officers have to go through, like police car driving, hand-to-hand combat, arrest simulations, shooting range exercises, etc. For our data collection, we mainly focused on two aspects, one being the shooting range and arrest simulations. So for the shooting range, there were 5 sessions which were focusing on different aspects of shooting. These would include shooting practices, different stands, handling instructions, etc. And the other one was arrest simulations, which is used to train officers in decision-making and proper intervention strategies when a firearm might be involved. So for this arrest simulation exercises, it was done in groups of 1 to 4 in a simulation and lecturing area as shown. So the instructor can actually manipulate the simulation exercises, which the participants see on the projector. And he can decide whether or not the perpetrator is going to coordinate with the police or is going to not coordinate, and hence change the simulation in real time. The police officers could fire rubber bullets, and there were rubber bullets shot back at them to keep the scenario as close to reality as possible. Now, for both of these different exercises, stress and mental workload ratings were collected using the NASA TLX workload index. So why do we want to go from short-term analysis to ultra-short-term heart rate variability analysis? First of all, if you just look at short-term heart rate variability on Google Scholar, this specific term, you'll find 6,000 odd results on this. And like with this variation of this term, there are even more results. For ultra short-term heart rate variability, however, you just see 500 odd results. Now, this is a big disparity. And a lot of it is explained by the fact that this is very new. And this focus on ultra short-term recordings is brought on by the fact that wearable sensors now make it possible for us to record these signals in real time, and there's a need for real-time quick decision making. So one of the evidence of this is that the first review along with the recommendations for ultra short-term analysis has come out in 2018. And shortly thereafter, we have studies done on stress and mental workload detection using these ultra short-term heart rate variability and indices. But something very important to note here is that this analysis has lacked is that these have been done with data collected in controlled laboratory conditions. So in order to do our analysis, we extracted features from this data collected for both heart rate variability and breathing. For heart rate variability, we used the benchmark time and frequency domain features, while for breathing, we made use of statistics in the time domain and some spectral analysis features. Now, just a summary of the analysis. I've already mentioned the data and the benchmark features. For epoch length, we went with the short-term heart rate variability window, which is 300 seconds. And for ultra short-term, we have analyzed 5 different ranges, starting from 60 seconds, going up to 240 seconds, which is 4 minutes. As far as the labels go, we have binarized the NASA TLX ratings. We have used subject-wise thresholds for this binarization, because this helps keep the data set more balanced so that the machine learning classifiers can learn it better. And subject-wise high and low mental workload ratings are easier to interpret for that specific subject. To further solve this problem of imbalance and use a proper evaluation metrics, we have used balanced accuracy. For feature selection, we have just concentrated on the top 15 features using recursive feature elimination. And validation has been done by 5-fold cross-validation, which was repeated 50 times using a vanilla SVM. Now looking at the results, we see that decreasing in segment length actually leads to performance drop for both stress and mental workload. For stress, this is a huge drop, like 7%, but for mental workload, it's still smaller for heart rate variability, like around 3.2%. Now, another aspect that should be noted is that multimodal fusion improves the performance over heart rate variability and breathing for both of these cases for stress and mental workload, with us observing a huge improvement of 8 and 6% for both stress and mental workload, even for the ultra short-term segments. Finally, something which is quite nice to know is that with a single heart rate variability modality, we would have a performance of around 60% and 57% for both heart rate for stress and mental workload. And this performance, we actually outperform these metrics with ultra short-term heart rate variability when we fuse the signals together. This is good news because it shows that even if we see a drop in performance going to ultra short-term heart rate variability but we can actually more than overcome this drop in performance using multimodal signal analysis. So in conclusion, the ultra short-term heart rate variability features, they showed a decrease in performance compared to short-term. The performance was greater for stress compared to mental workload, but fusion actually overcame this drop in performance when it comes to single modalities with short-term heart rate variability, which is good news, as it shows that multimodal fusion is the key to just detect and get good performance for stress and mental workload models while taking into account real-time user feedback. So if you have any questions, you can reach out at my email, which is mentioned. And thank you so much. Merci beaucoup. And if you want, you can connect to me on Twitter. So thank you so much.